this further. 9 players on a baseball team still. I want to select only the first 5 players to randomly line up to bat. How many ways can I just select the first 5 players? So again, this is still, again, an extension of the multiplication counting, the fundamental counting rule. Because I still have 5 spots, and I can determine how many options for this and how many options for that, and multiply them all out to get the total amount. But for my first player to come up to bat, how many choices do I have? I still pick from the 9 total players. So I still have 9 total options, right? Once I pick him, I have only, how many for the second? 8. And then, of course, for the third, 7, good, 6, 5. This time I'm not going down to 1 though, right? I'm not going down to 1. So this is not factorial. That factorial symbol only applies when I'm going all the way down to 1. So that is not going to work here. Okay, something else works. But first let's find this number. How far did I go down? To 5. So 9 times 8 times 7 times 6 times 5 is 15,120. 15,120. 15,120 ways that I could do this. All right, now, do you agree that order matters here? The order in which I select these people matter, right? I kind of said that before. I used, Dade and A, even though I don't like A. Maybe I should say, well, anyway, getting sidetracked. There are 2 rules that are popping up here, okay? One is called, well, hold on. One is called, that is not an R, I want a P. The Permutations Rule. I don't know if you guys have ever heard of this. The Permutations Rule or the Combinations Rule. And there's a similarity between the 2. Now, the requirements for the Permutations Rule. Let's start. We're going to select, hold on one second, Marissa. We're going to select R out of N, total, whatever. I'm selecting a piece of a total. Now the same thing applies for the counting, the combinations rule. I'm just going to say, actually I'll just say same, okay? I'm selecting a piece of the total. R represents the piece, N represents the total. For permutations, order matters. So, usually they say ABC is not the same as CBA. That means if I select 3 letters, A and then B and then C is a different part than C and then B and then A, even though they're the same 3 letters. The order in which they are selected matters. But for combinations, order does not matter. So I'm selecting a piece of the total. For permutations, order matters. For combinations, order does not matter. And so if I have permutations, the notation for permutations is RPN. I'm sorry, NPR. NPR. There's a formula is equal to n factorial over n minus r factorial. Combinations and CR, or I've seen it like this, N and then R, okay, almost like a matrix. There's no division sign. Sometimes this is the notation for combinations if you ever see it that way. This is the one that the book uses, NCR. And this is N factorial over the, N factorial over the quantity, N minus R factorial times R factorial. It looks overwhelming, not that bad. I'll show you how to use the formula, but there's also a calculator trick. Okay, so let's go back to this example here. Let me see if this applies for this example. Does it apply? Well, am I selecting a piece of a total? I'm selecting 5 of 9 players. So let's do my N would be 9. Let me do it in a different color to show that now I'm using, one of these rules. N would be 9, my total. And R would be 5. I'm selecting that piece of that total. The question is, for this though, does order matter or does it not matter for this particular scenario? Will somebody tell me that? Does order matter? Yes, order matters. Well, I have a situation where I want to determine a total amount of something. I'm selecting a piece of a total. I'm not, ordering all of it. I'm selecting, trying to order some of it. Order is mattering, so I'm using permutations. N is 9, R is 5. So I have 9p 5 equal to, following my formula, n factorial. Here n is 9 factorial over 9 minus 5 factorial. Now, I'm going to show you how to use the formula. 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. I want to show you how this works. Sometimes you're asked to just simplify these kind of things. 9 minus 5 is 4, and I'm doing 4 factorial. So that is 4 times 3 times 2 times 1, correct? Right? 9 factorial is 9 times blah, blah, and 9 minus 5 is 4, and 4 factorial is 4 times 3 times 2 times 1. If you remember fractions, you have multiplication on top, multiplication on the bottom. You are allowed to cancel anything that is in common on the top and on the bottom. So 4 down is gone. 4 factorial is within the 9 factorial. The 4 factorial is out. And I'm left with 9 times 8 times 7 times 6 times 5, which is exactly what I had up here, just using the fundamental counting rule. Okay, awesome, right? I get the same thing using the formula, which is going to be 15,120. Let's see what happens when I use my calculator. Remember what I want to do. I want to do 9p5, right? 9 permutations, select 5. So how do I do that? I don't know if you noticed, when I went into math and I went into prob, you see 9PR and you see NCR. Or NPR and NCR. Permutations and combinations are here as well with factorial. Okay, but I can't go straight to that yet. Let me go back to my screen. I first have to say what n is. N is 9. Then I'm going to go to math, and I'm going to go to permutations, because that's what I want. Enter. And then I'm going to tell it what R is, which in this case is 5. Now, if you have a TI-83, it'll say 9 and then NPR and then 5. Mine is fancy, whatever. Enter. 15,120, same thing. So obviously a little bit faster than the formula. But I mean, just so you know how to use the formula, and just so you know. I did say initially in this class, you guys are going to be all happy if you have your calculator. This is another example. Not saying you can't do it with the without the graph and calculator, but obviously it's a little bit faster.